Okay, we have made it to chapter 2. By the way, there's 19 chapters. So, one thing at a time. We're in number 2. 19 not this semester, that's the whole year, but anyway. Okay, functions versus relations. This is chapter 2, which is all about functions. And relations are just a set of two numbers that kind of go together, like 2 comma 3 and 3 comma 4 and 5 comma 19. And yes, you can sometimes have functions where you really can't predict terribly well what's going to come out when you put in your x, your input. Okay, I want to just talk about that for just a moment. The first number in the group, those are called the inputs to the function. They're also called the x's, and they also make up the domain. Can any smart kid tell me the other side? Outputs. Yes, keep going. They're the y's, and they make up the range. You got it. And you need to keep those straight. Domain and range are going to be kind of a big deal in this class. Today we're just doing baby domain and range kind of problems, but it's going to become a big deal. Okay, so next, how do we know if it's a function or not? Well, any set of two numbers that go together makes up a relation. Okay, it's not hard to be a relation. Any two things that are related. Now, the question of whether or not something's a function is whether or not any one of the inputs ever ends up giving out more than one output. So, like, for instance, right now, from the evidence I have, if this was my complete set of data, then it's a function. Because every time I put in a number, it gave me a unique answer. Now, if I put in a 2 again, it's a big moment of truth. If I drop that into the function, what better come out? A 3. Because that's what came out last time. And if I put a 2 in and it comes out to be like a 7, do you get how now this is not a function? That's what it's all about, is if one x value is mapped to more than one y value. Mapping is just a way of saying connecting, okay? So this, as soon as I added that last point, is not a function anymore. If I erase it, now it is a function. Okay. So let's talk about what that would look like in a bigger set of points and how to say this officially. All right. Does anybody know what this little statement is trying to say? X is what? E? Can you clue what that little symbology means? An element of. X is an element of big X. Okay. What if it had said, this one I think you maybe know, a big R? Do you know what that means? Certain kind of number. Not rationals, that's a very good guess. Something like that. Real. X is an element of the real numbers. Okay. All right. I'm not going to take much time on this slide. It is neat to know how officially you would say this, but if you ever said this at like a party and said, well, actually f is such that the set of x maps into the set of y, where f of x is equal to f of x plus, no, 2f of x minus 4, you'd probably just confuse everybody, including yourself. Okay, I know that that's the official way you describe a function, but in the real world, we really don't need to say that or use that very much. It's kind of like a lot of definitions out there. Kind of wordy and sometimes confusing, but if you need to go back to what does it really mean, that is the definition. All right, let's say this little set right here. Let's say I said it was a function. How could you prove me wrong? One gives you 3 and one gives you 5. That means that one input has what? 2 outputs, and that's not okay. Just to clarify, do you notice that this output comes up twice? But that was not a problem. In fact, everything could have an output of 7. You put in 1, you get 7. You put in 2, you get 7. You put in 3, you get 7. Put in 9, you get 7. That's not a problem. You can do that. Okay? The only problem is if I repeat one of these x's, then it better come out the same as last time. So if I put in 2, it better give me a 7 again. That would be a function, all those blue points I just wrote. Okay, so again, we just proved that this little list right here was not a function. And you can tell that by looking at the coordinates. Do you remember the whole vertical line test? That's another way to tell if you have a function. We talked about this one the other day. It was cool because it had what kind of symmetry? X-axis symmetry. And it was not y equals x squared. It was x equals y squared. Is that a function? No. Because when you put in an x value, like let's say 9, for the x, do you get there was 2 ways to get that? Two things that would come out for an x value of 9? 3 and what? -3. See how it's getting 2 outputs for an input of 9? 9 being the x. Okay, so moral of the story, you can look at the graph, see if it passes the vertical line test. If it ever touches twice like this one does, then it's not a function. All right, third way to tell if something's a function is, does it have an equation? Well, see, that's not a great way to say it because I just showed you one that had an equation. X equals y squared. That wasn't a function. So just because it has an equation does not mean that you are proving that it is a function. All right, let's move on. Consider this function. And here is the function of the day. F of x is 3 minus x squared. Okay, find f of 4. Would you please just stick 4 into the function? By saying f of 4, do you get they were telling you that x is 4? Because, you know, that's where x usually goes, right? F of x. They're saying that x is 4. So in your head, quick, pop in a 4. Then I guess you got to square it. You go 3 minus that. What'd you get? -13? Raise your hand if you agree. Okay, good. Now, what if they say f of x is equal to 2? Kind of sounds like I'm supposed to stick a 2 in, but I can't put it in the x. They didn't tell me the x. Well, if f of x is equal to 2, then I'm putting a 2 right there where f of x is. 2 is equal to 3 minus x squared. And then I solve it. And this one is one of those ones where if you don't do it right, you're going to just get a quick, easy answer and it's going to be wrong. Do it carefully. Please solve that one carefully and figure out what x is. If you get a quick, easy answer, it's probably wrong. I'll pause for a second. Let me try that. All right, so we are solving this down, and we have got absolute value of x is equal to 1, x equals 1, and x equals -1. You are correct. Those are the 2 answers. Anybody have a question about that one? All right, then moving on. F of c. Well, that's pretty simple. You just stick c in the equation. Where? Did they give you an x or did they give you a y? Give you an x. The x is c. I know that feels weird, but the thing you drop in the x spot is a c. So you put a c right there, and that's it. 3 minus c squared is your answer. And that's, of course, f of c is 3 minus c squared. Okay, f of c plus 1. Well, then you just got to put a c plus 1 in for the x. So I go 3 minus empty parentheses, and I'm going to drop in whatever I should for x. What should I drop in for x? C plus 1. Now, here's a common screw-up. Guess what everybody thinks c plus 1 squared is? C squared plus 1, or 1 squared. It's not, because it's c plus 1, and then c plus 1, and then that's what squaring really means. So first, outside, inside, last is going to give you c squared plus 2c plus 1. So final answer, 3 minus c squared plus 2c plus 1. And actually that 3 and that plus 1 should probably go together. So it's minus c squared plus 2c plus 4. There's your answer. All right, let me challenge you with something. That what we just did there was letter D. We put in c plus 1, you know. What if they had said equals 10? We just figured out what f of c plus 1 is, right? It's right there. So then all you'd have to say is equals 10. Equals 10. And now I could solve that equation. Well, I would subtract 10 from both sides, and I'd end up with a negative 6 right here. And then hopefully I could factor it. If I can't factor something that's a quadratic, what's the last resort and solves all quadratics? Quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right. That's if I needed to solve it, if I set it equal to something like 10. Because we already had this answer. And now we just say, oh, that was the answer for this. Now we just say equals 10. Okay. The last one you have here, before we start talking more about domain and range, is f of x plus h minus f of x. Well, first I should do this. In the x spot, I'm going to put an x plus h. So I'd go 3 minus x plus h squared. Same deal where you got to split that up into 2. I don't need you to do that right now, but you get how it's just like the last one, right? And then it says minus f of x, but that's just f of x. That's just this. But here's the really common mistake. People write this. Minus f of x, which is minus 3 minus x squared. What do you need or it's going to be wrong? Parentheses. Do you get how, if I just follow this out and I have a minus, and I say minus, and then I say f of x is just this, if I have a parentheses, it'll make the negative distribute to both of them, and that's really important. So easy to just drop a parenthesis and lose a point there. Okay. That covers all we need to know about that. Now, notice it says end of the notes for day 1. There's a whole bunch of day 2 notes I'm going through right here, which we will cover on Monday. And there was this key slide. I tried to insert these into the smartboard so you could find where we are. That's the end of the day 2 notes and the start of the day 1 homework. So there's the start of our homework. I'm going to make your assignment just a little easier for, we had a problem like this on your test already, so we're going to skip that one and not worry about that one. Now let's go up and do number 2. In 2 through 10, obviously we're only going to do 2, 6, and 9. Determine whether or not the relation represents y as a function of x. Okay, so basically what we're trying to do here is just check, is this thing a function? So here's all my x numbers. Did it ever repeat? So then we can tell, did it come out the same when it repeated? There's the one where you had 4 going in once and you had 4 going in a second time, and they're different. So this is not a function. Okay? Yay, don't have to do any more, because if it's not a function, then its domain and range are kind of irrelevant. It says find the domain and range of those which are functions. I'll tell you domain and range in just a sec here. All right, x comma 1, where x is an irrational number. Irrational number, comma 1. Can you name any irrational number? Pi is an irrational. So would you agree that pi comma 1 would be one of your points? Okay. Now think about this for a second. Does it even matter what I put in for x? Don't I always know what output's going to come out? Is there any way for this thing to not be a function? Get what I'm saying? Like if I put in pi again later, isn't it going to have to come out with 1 as an answer because of that? So you see how this one is no way for it to fail. There's no way for this to not be a function. Okay, so it's a function. Yes? X is an irrational number, meaning I guess you could say x is the set of all irrational numbers. So it can be either or, but if you're going to have more than one point to even be able to tell if it is a function, then we should probably consider more than one irrational number. But I hear you, it's not super clear on that. All right, so now you get how it can't, like you can't put in pi and get something different, and therefore it's got to be a function. If we got that part, it's a function. That's the first part. Determine if it's a function. Done. Next part is domain and range. The domain is the x's and the range is the y's. Do you remember that from the very first slide I showed you? Domain's x's, range is y. I'd like to look at some pictures first to do before we do this. Let's look at some real typical graphs that you're used to. Like that's a parabola, right? Domain is the x's. And the domain is what's the smallest it can ever be when it comes to the left-right. This one's domain would be negative infinity to positive infinity. You're right. Very good. The range is up-down. It's the y's, right? Y's run this way. Now, this is important. You always have to put the smallest number first. What's the smallest that the range can ever be here? 0. And if this was, technically I'm not touching 0 here, but I'm going to move it down. There, it's touching 0 now, so I should put a bracket on the 0. It goes from 0 to, what's the biggest it'll ever be? Infinity. Good. Seems like you guys remember range and domain. That's good. All right, let's look at a weirder one. This is the square root function. What's the domain? The x numbers. 0 to infinity. Good, because it's going from 0 to forever that way. Range runs the other way. Oh, thank you. Bracket. And then range runs the other way. So what's the range on this puppy? 0 to infinity. Positive infinity. It's going up. So, all right. Now, they're easier to tell whether or not they're a function because they're a picture. Is 15 a function? Yes, because it passes the what? Vertical line test. Is 16 a function? No, so you're done with it right away. Is 22 a function? No, so you're done with it right away. You don't need the domain and range for it. Is 26 a function? Yes. Let's do the domain and range on that. What's the domain? How far is it going to go this way, and how far is it going to go that way? Negative infinity to positive infinity. And then the range is how low to how high? Negative infinity to how high? 4. All right. So you're pretty much doing all the homework for tonight. You're going to be giving me your test at the door. If you have issues with your test, you're going to wait till the end so that we don't make the whole class wait for you.